Hey Mike, I'm making this video for you, man. I won't be there next year, but I pretty much have failed every micro test, but I've learned from it. So here we go. Here's micro in a nutshell. First part is just on diodes. Alright, so recall the passive sign convention. Current flows like water from more to less pressure. This is positive current, or you could say current entering a node is positive. This one you probably already knew. But mass falls from higher potential energy to our zero reference, i.e. the ground. So charge falls from higher potential to lower potential too. I never really thought of it like that, but if you have like a wire, the charge is falling sideways through the wire. That might help you with this part here. This is a symbol for a diode. Look at the hash line. It is where that negative sign is. Conventional current goes from higher to lower potential. And this diode is on when it does that. And by the way, that little hash line, that's called the anode. And the anode is always less potential than the cathode. Diode is like a check valve in my mind. You can Google it. Wikipedia has a little animation, pretty much of the same thing, but this is a voltage source because it's making electric pressure, if you will, through the water. Check valve is like a little hinge, and there's a stop block right there. So pushing that way, water goes through, diode is open. We flip this configuration, just like I flipped it right there. So if the motor or whatever pushing on it, no water is going to be felt over here. There won't be any pressure felt over there. So, and look, it even looks like these are like your charges. Yeah, they're going through here. This one, oh man, they hit the wall. So when you see that, it's off. So it's real easy with DC stuff. Thing you got to remember for AC, just recall that the charges, they shimmy back and forth. They shimmy forward during the positive alternation, and they shimmy backwards during the negative alternation. So this was like a test question we had or whatever. You guys see that? Okay, so check this out. Right here, the sine wave. First thing I do for AC and diodes is I draw what the sine wave would be like. So here it is. And then I'm going to just like mentally put some positive charges on here. Maybe some random spots, just in my mind, you know. I imagine like bobas going through a boba straw, like up and down or whatever. So I'll do the positive shimmy now. So these little bobas are going to go like, they're all going to move forward. This one makes it through. Alright, so that one's good. This guy made it through. This one didn't make it through. Oh well. These guys going forward. Okay, this one wants to go forward. Now he's got a choice. Does he want to go through a resistor and have to do some hard work to do that? Or will he just go through this easier path? He'll probably go through the easier path. Okay, so now I'm going to color that in, I guess. Here, just put the little... There we go. Alright, so positive shimmies, they all make it through. Alright, now I'll do it in red. Here's the same bobas, if you will, spread throughout the thing in your mind. Everywhere through the wire. Alright, now all these guys they're gonna go other direction. Okay, what happens? We're at the VO. Alright, so trying to do boba shimming the other way or whatever. And so this boba right here, this positive charge, I keep saying boba. Boba is, if you ever have Thai tea, it's a little tapioca ball in there. And if you're from California, you already know. But anyway, so it goes that way. And so this guy can't make it through. This guy can't make it through. Okay? This guy makes it through, but then can't go there. So all of our positive charge that are trying to shimmy on the negative alternation, they don't really get to make it from VO back to V1. So in a sense, it's kind of like VO doesn't get to feel the pull of this guy like rushing that way a long way, because eventually, maybe it only in your mind it only moves like a half an inch, like because eventually it goes through here, but it gets stopped right there. So it doesn't. It's gonna be flat line right there. Okay, that's kind of a hard one, I guess, to do the mental shimmying thing with. So let's check out these other ones. Okay, I'll do the same thing. My method is draw what the sine wave would be, and then fill in the positive shimmy, and then the negative shimmy. Alright, and I'm not looking at like the answers while I do this, so. Alright, so there's that. Randomly throughout the whole wire, put my chargers. Alright, we're all going to inch forward 1 inch. This guy made it through. So did this guy. Okay, now I have a choice. We can go through this big resistor or easily just go to VO. I think we all make it through VO. So positive, now let's do it on here. Positive alternation, definitely all made it. Okay. Now, check it out this way. Keep the same dots. Same guys. Instead of inching 1 inch forward, we're all going to move 1 inch backwards and just see. Well, we get to here. Oh, I can't do it. Oh, I can't do it. I'm encountering that wall right there. It's graphically drawn to look like a wall. Okay, so, but this guy originally right here. Let's see. I never drew an arrow for him. Well, he'd be going up. Okay. So the question is, does this one get to feel the pull? And I say no, because there's no way for it to go. Okay. Actually, I do have the answers over here. I am going to look at this one. Alright, the rest of them. Same thing. So this is sine wave. I will throw some charges all throughout the wire. Okay. On the inching forward, that one made it through. They both make it through. Okay, I can this guy goes down too. Why not? Want to go down there? No, go through there. Okay. Inching backwards. Dang it. Can't go through there. Can't go through there. That's accurate. All right. All right. Inching forward. Inching forward. This one would be a short to ground because it will go down through there. There's no, be different if this, it's like, I don't know, some sort of load or something, but it's not, just, it's like a terminal or whatever. So this VO would be the same as if we took VO here, essentially, whatever. This is short to ground, so on the positive alternation, it's 0. And now, same guys. Oh, this little charge, he won't make it. but this one will. We do get to feel a pull on VO, VI, VO. Finally, one with a negative alternation. If this one would have been drawn differently, let's do that one. What if it was like this? Okay. The charges are all throughout this wire when we got it. Okay. Engine forward, makes it through. Engine forward, makes it through. Not this guy, but so here we are. Alright. Do I want to go V out or through resistor? I'll go V out. So that's what happened on the positive alternation. Now, same charges. And right here. Went that way. And the ground, going up. Going this way. Hit a wall. Ah, made it through. Man, hit a wall. Well, that didn't change anything. It's hard to find examples of ones with negative alternations, but what if this? All right. Okay. Nope. Yep. I'll go through VO. Alright. Gee whiz. This is another one. Like the exact same thing. Okay. Alright, now the same charges. This guy would have went down, he's going up. He's going that way. He makes it through. Oh, he made it. He made it. Alright. So this thing didn't really do anything. It's still a sine wave. Alright, cool. So there's an example of some more negative alternations being felt at V out.